Once upon a time, in the Stracuzzi household, Mr. and Mrs. Stracuzzi were having an argument, sometimes called a discussion, about whether or not hot water or cold water spreads things out faster. It's not important why we were arguing about this. The point is, I'm always right, but he doesn't believe that. So I had to prove to him that hot water does in fact spread out dye faster than cold water. So since I'm a science teacher, I just happen to have all kinds of scientific equipment at home, So I grabbed a beaker and a flask, and I got some food coloring, some green and some blue, and I got some hot water from our coffee maker, and some cold water from the sink, and I added some ice to my cold water, and then I squeezed a little bit of dye into the hot water and a little bit of dye into the cold water at the same time. And presto changeo, after 5 minutes, you can clearly see that the hot water has spread the dye out faster. Ha ha, I said to my husband. You see, I'm always right. I'm a genius. Of course the hot water spread out faster than the cold water. And then I proceeded to explain why that's scientifically true. But my husband said, Smarty Pants, I don't believe this experiment at all. First of all, you got twice as much water in your cold container as in your hot container. So the reason your cold water spread out slower, genius, is because you have more cold water, so it's going to take longer. Plus, there's ice in your cold water getting in the way of all of that dye trying to spread. And another thing, he said, I've noticed that you used 2 totally different containers. One is a flask, one is a beaker. They're shaped differently. I'm sure that's affecting things. Oh, and also, you use 2 different colors of dye. Clearly, green dye is thinner than blue dye, and that's why the green dye spread out faster. So I said to him, I really think you should have married somebody else. Well, I had to redesign my experiment to convince Mr. Stracuzzi that of course I'm right. I mean, I'm a science teacher. Of course I'm right, right? Well, maybe you think I'm right, but this experiment doesn't show that I am, does it? If you really think about it, my husband is absolutely correct. I can't really tell what caused this container to spread out faster. It could be the shape of the container that it's in. It could be the amount of water is smaller. It could be because there's no ice. It could be because the dye is green. Or it could be because the water was hot versus colder water. It could be any of those things. One of the vocabulary words that I had you guys looking into on that sheet is something called constants. Constants are all the things in an experiment that you want to keep deliberately the same between the thing that you're testing and the thing you're comparing it to. So I'm trying to compare hot water to cold water. And the only thing that should be different between my 2 tests is the temperature of the water. I should either use 2 flasks or 2 beakers. I should either use 150 milliliters or 250 milliliters of water. If my water needs to be cold, I should avoid making it cold with ice if I don't also put some kind of object that's ice-like in my hot water, and so on. And so I redesigned the experiment and I redid it with him, and I won't tell you what actually happened during our experiment because I want you to redesign this experiment so that it is, in fact, a fair test of the question. This is not, mainly because there aren't any constants. But also, there are procedural errors that I want you to notice. Notice that I've taken hot water and cold water and put them right next to each other, which pretty quickly, the 2 containers actually evened out their temperatures because they were so close. I noticed that after 5 minutes, I really couldn't tell anymore which of my containers had started out hot and which had started out cold if it weren't for the ice. The other thing is, you want to be careful that you don't shake one container more than another or bump into your surface. This is very common in our classroom because of the lab tables and the way that they're, not exactly totally flat on the ground. So you want to be really careful that you're not shaking anything up. So when you design your experiment and come up with procedures for testing what you want to do, you really need to think about this. And one other suggestion I would make is that it's never a good idea to run just one trial in an experiment. Anything could go wrong the first time. Maybe when I was squeezing the dye out, maybe I didn't squeeze them both at the same time. Repeating the experiment multiple times, preferably as many times as you can fit reasonably in the amount of time you have, is always a good idea. This is similar to if I were to give you a stack of money and say, hey, if I'll let you count this money. If you can tell me the amount that's there, you can keep it if you get the right answer. Imagine that it's a big stack of ones and I let you count it. You would want to count it as many times as you had time for, right? Because if you did it only once, you'd be afraid that maybe you made a mistake. Maybe one of those dollar bills escaped you. But if you get to do it 4, maybe 5 times, after a while, if you keep getting the same answer, you're going to start to feel like, you know what, I think I know what's going on here. So when I repeated this experiment with my husband, we made sure that we repeated the experiment. We actually did it 5 times, and all 5 times we got the same results, and that helped us become more confident, not only that we knew the answer, but that we had run a fair test to get to the answer. So think about how you want to set your experiment up. You can use flasks or you can use beakers. You can use my hot coffee maker to get yourself hot water. The water that comes out of the sink is quite cold, so you really don't need ice to make it cold. And I have lots and lots of food coloring in lots of different containers, and you can choose what color of dye you want to use and so on. And think about how you want to run the experiment. Do you want to actually time it, or do you want to do what I did and just have a time limit at which point you check to see which is more spread? Some people like to let it go until one of them has totally spread out and the other one hasn't, and so on. So you have to think about what you're going to consider done. And another point to think about is sometimes you have to make a decision about if you're going to go with the doneness, which one's done first idea. You have to ask yourself, can you tell what done looks like? And in order to know that, you might want to take some dye and put it in some water and stir it up so that it's evenly spread out so you can see what totally done looks like, sort of as a point of comparison. Because sometimes people think that this hot water is totally spread out, but if you look closely, you can see at the top it's not as spread out as it is at the bottom. So that's another thing to think about. So take all those things into consideration. Look at your lab sheets, either the online version or the hard copies. Fill out a hypothesis and a rationale. So I only gave you my hypothesis that the hot water would spread first, but I didn't give you a rationale, and I did that on purpose because I want to see what ideas you have. And then, after you have a hypothesis and a rationale, using the vocabulary list that I gave you, see if you can figure out what the different variables are, what the control groups are, the experimental group, etc. That second sheet might give you a little trouble. You might need a little help from me, and that's okay. You can ask for help. And then list those procedures that you're thinking of, and then later you'll get into a group and discuss with your group whose procedures you want to work on. So if you're doing this on the actual lab sheets, I strongly recommend filling those procedures in lightly and in pencil so that you can erase them to put down the final procedures that your group agrees on, because it probably will change. See you guys in class so that we can do the FAIR test experiment.